What we're looking at right now is a table of some values. And if you didn't see this f of x here but saw it as a y, you're thinking, all right, no problem, I can handle this, Willie. You want me to graph it. Well, you know what? Down the road, I think we will want you to graph it. But we want to start thinking about it in terms of how does it relate to what a function is. Because functions are very specific ways that we can look at information. And they help to keep a standard for us as we can be consistent throughout the things we're doing. So I have a table. I have an x column and an f of x column. Well, the first question is, I want to find out, is it a function? Well, you know the first three letters of function are fun, so I think we're well on our way. Is it a function? Well, we need to find out, does every x value we have match up to exactly one y value? So as I'm looking at the x values, negative 2 equals a 5. Well, every time I see a negative 2, it must be a 5. Negative 1 to 0, 0 is a 3, 1 matches a 1, 2 matches a 4. I don't see any duplicate x values here, and if I did, they would have to match up to the exact same value that the previous one had. So I can claim this is a function. But if you want right now, if I happen to just change this one to a negative 2 right there, this is no longer a function. Because a negative 2 at one point equals a 5, but down the road a negative 2 equals a 4, it can't do that. It can't change. So this in this form, it's not a function. But if I go back to our original problem, we are a function. And remember the first value, all my x values, or my input values, those represent the domain. And the second values, the f of x, or the y, or the output values, those represent the range. A couple of questions I want to ask is, well, let's say for example, I want to find out what f of negative 1 is. Well, that's asking us is what happens to the function when my x value is negative 1. And we can just observe through the table of what it is. I look for a negative 1, and every time I get a negative 1, it makes a 0. So I can say that f of negative 1 equals 0. What if I want to find out another one? What about f of 0? What can be said about f of 0? Well, I have a 0 here and a 0 there, so I think that's probably where I'm going, but which one do I look at? Well, remember, this value inside this function that represents our domain value. So I want to look at the x value here is 0. So what's f of 0? It's this one. And every time I have a 0, it makes a 3. So f of 0 equals a 3. And lastly, one other part that we can kind of look at is, I want to say something like f of x equals 4. Kind of changing it up a little bit. But basically it's saying is my answer is a 4. What's the x that makes it a 4? Well, we go over and look at our table. We want to look at all the answers and find out where the 4 is at. The 4 is located here, and this table of values, or a function that we talked about, said a 4, I can get a 4 by putting in a 2. Every time I put a 2 into the function, I should expect a 4. So it would be correct to say that f of 2 equals a 4. I hope this is helping you a little bit as we start to crunch through some of these things.